wonderful to see a lot of familiar faces and to be able to talk about this research agenda that I've been following for a while now on data confidentiality. What I want to do is okay. Can you all see that just fine?
Mm-hmm.
Yeah. Okay. Great. What I want to do is tell you about a vision that I and others have for enabling researchers, policymakers, students, etc., to get access to confidential research data, in particular research data on, by confidentiality, I'm thinking data on people, but really it could be data on businesses or anything that's confidential. But for our purposes, we can think about people. And I'm going to go through my talk, and I will pause for questions. I encourage them throughout. Don't have to wait to the end if you have them. I'll stop. You can feel free during those silences to just shout out, or if you do something in the chat, somebody might see it and somebody else can shout out. But I encourage questions throughout. Okay. This is work that's been supported by various grants over the years. All the opinions, of course, are mine. They are not the opinions of any of those funding sources, especially the Census Bureau, which I happen to hold a part-time appointment with them as a mathematical statistician, helping them think about privacy issues. So let me start off my talk with a statement that probably is not too controversial here, but in some places it actually is, which is I believe that record level data are enormously beneficial. Right? Data on individuals, humans here, individual people. Okay, why? Well, of course, data on individual people that we get to analyze facilitates good research and good policy making. Right? There's no substitute for having actual data as opposed to, say, a whole huge number of tables when you're thinking about trying to dig in and understand what's going on for research and policy making purposes. But not only that, there are lots of other benefits to having record level data. Students need to learn how to analyze data, and having data sets available enables them to do that. Those of us who like to develop methodology, we need data sets in order to experiment with our methodology with. Right? If we don't have data sets, it's really hard to do that. And of course, it's not only researchers and students, but just ordinary citizens. For example, a lot of business people like to use data from the American Community Survey and other census products to try to figure out, well, where should I relocate? Where should I put up my business? So helping citizens understand their communities. I think having access to data, record level data, is really important, even in this world that we're moving towards in some ways, where we have to bring the analysis to the data because the data are so huge and we can't download them onto our laptop. Even in that world, having some kind of data set in front of you, even if it's a subsample, it can really help your analysis, because it can help you think about what even are the right questions to ask. It's hard for me to think about how do I decide what questions I want to go after if I don't have some data in front of me. Okay. Of course, this is challenging nowadays. It's been challenging, but especially nowadays, because the types of data that we're interested in, we're ethically and often legally obligated to protect the privacy and confidentiality of data subjects' identities and sensitive attributes. And you can do things like strip off the person's name or social security number or address, etc. And those are necessary things to do, but they're often not sufficient to do. Maybe there's only one Native American woman, age 54, working for the state of North Carolina. And if the data steward, I'm just going to say agency from now on, if the agency releases information on age and sex and race and occupation, then maybe somebody with access to an external data file might be able to identify her and then learn sensitive information about her. Okay. In the old days, maybe that wasn't such a real threat, but now with the just massive proliferation of data everywhere, credit card companies, hackers, I mean, there's so much data everywhere. We worry a lot about this. And statistical agencies, of course, have been thinking about this problem for a long, long time. And so in the past, what they've done is they have fuzzed up or altered the data before release. So if you go download a public use data file from a government agency, say the American Community Survey, PUMS, or a data file on the Consumer Expenditure Survey, or any of these surveys, those data have been altered. You're not getting the actual data. Okay? They've been altered for lots of things, but one of the main things they've been altered for is to try to reduce the disclosure risk to the participants. And these are some of the historical techniques that agencies have used and still use today. Aggregating data, suppressing data, swapping data, and adding noise to data values. So let me talk a little bit about those to give some context for the vision that I am pursuing. So aggregating data, this is by far the most popular method, right? So examples of it include coarsening geographies. Instead of releasing data at the address level, release only the state or maybe the metropolitan statistical area. Top coding, those of you who do analyses of monetary data, you might see data that are top coded. The released value is 100,000 or more. It's not the actual data value. Collapsing categories, making broader categories. And the whole idea with aggregation is that you're trying to kind of reduce the granularity of the data so that people hopefully become less unique, right? That there's a lot of people in the state, but not so many people on my street block, right? And so hopefully that reduces the risk. That's the logic behind it. Data suppression, just blanket. Right? Take it away, or blanket entire variable. This is done particularly in tabular data a lot. You see these tables with these asterisks in there where the data have been removed because the cell size is too small or something, but it can be done for microdata too. Swapping is you sort of take one record's values and switch them with another record's values. So this is the go-to method, or has been, no longer, but has been the go-to method for the Census Bureau for their decennial data products, and as well as the American Community Survey. It's also the go-to method for the National Center for Educational Statistics. So this is a very, very popular method. And the idea with swapping, the idea is that, well, if an intruder thinks that she or he may have identified someone, then, well, maybe the agency could say, no, maybe you didn't, because that could have been a swapped record. You could have, think you got somebody, but we may have switched their values with somebody else. So it's kind of a protection by perception. And then adding random noise, take an income and add some random noise to it, are very popular with business establishment data. Sales, I'll just add noise to it. So these are done, and in the past they were done with what I would call low intensity. So for example, the percentage of records that get swapped. Well, in the census, actually nobody. Well, it's not true, not nobody. That's a Census Bureau secret, right? So very, very, very few people know the swap rate for the decennial census. We all think it's small, but nobody really knows what it is, and that's ostensibly to protect people. If they ever got called in front of Congress, they could plausibly deny that they know the swap rate for the decennial census. I don't know why Congress would ever want to ask about what the swap rate is for the decennial census, but nonetheless, they have that protection. And so, kids just got home, sorry. So swap rate, we don't really know. We all think it's small. Why would they apply these things at low intensity? Well, because they don't want to perturb or hinder the quality of the data too much, right? You can imagine if you if you did like 100% data swap, right? You swapped a huge fraction of values across records. All the associations among the variables would be severely attenuated, if not obliterated, right? The variables that were involved in the swapping. And so, so that's why they tended to do low intensities. Or if you added random noise and you had this humongous noise variance that you added to the data values, you really obliterate what the shape of the distributions look like. And everything would look like an outlier. It'd be a mess, right? So the noise distributions tend not to be too large. The problem with those things nowadays is that I don't think they're adequately protective. Maybe in the old days when all the data were behind the firewall of the agency, they were adequately protective, but it's the opposite. All the data are out there in the wild, right? And so, you know, a 1% swap rate. I don't know if that's the right swap rate at the decennial, but let's just say it's 1%. I have no idea. This is not, I have no insider knowledge here. But let's just say it's 1% just to make up a number, right? That means that 99% of the cases are true values, right? They haven't been touched. And so an intruder who thinks, yeah, I identified Jerry, there he is in the census file, you know, the PUMS data, I know all this information about him, there he is. They're probably right, because it's probably I haven't been swapped, right? And so low intensity perturbations, not protective. High intensity perturbations really can degrade the quality, and in ways that are very difficult to unwind or understand, right? Like if you did a humongous swap rate, you got that data, I don't know how you'd analyze it in any way to know that you're doing a good job. Okay, so that's kind of the state of affairs still, although it's changing. Let me pause and see if there's a question. Okay, great. So,
sorry, Jerry, quick question.
Yes, yes.
Can you elaborate a little bit on the swap variable? So how do they choose the variable to swap? So how?
Yeah,
it's out of curiosity. Yeah.
Yeah, it's a good question, and it varies a lot, and sometimes some agencies don't really tell you very much in their documentation. They have a fear, perhaps justifiable, that someone might be able to unwind it if they knew too much information about the swapping. But I can give you an example in the decennial products. What they'll wind up doing is they'll take a household that looks similar to my household. So for example, 4 people in my household, and I'm in Orange County now, and they'll swap me with somebody in, say, Durham County or some other county. It would swap my household with another household that is 4 people, for example, in a different county. And so all my characteristics, you know, from Orange County are now going into Durham County or Person County or whatever county they pick. And how they pick the counties, I'm not 100% sure. There has to be some randomness in there too. You know, well, it doesn't have to be, but there usually is some randomness in there too.
What I'm curious is, how do they know that they're not screwing up something important that someone wants to measure by doing this switch?
They don't.
No one knows. Okay, all right. That's what I want to know. Thanks.
That's the point. They don't. They really. I mean, to the agency's credit, at least some of them, you know, that they do some kind of quality checks, but you don't know for sure. Okay, so here's the beginning of the ideas that I've been working with that I'll illustrate to you today. This was an idea that was proposed by Don Rubin, who happened to be my PhD advisor, and but my thesis had nothing to do with this. But it's to make what's now called synthetic data. And basically what we do here is we create statistical models that try to describe the important relationships that we see in the data, and we simulate new records for this public use data set. And we release those simulated records. Okay. Now, let's think about what some potential advantages of this idea are. If we can do it well, and that if is a massive if, I admit to that. But let's see. One potential advantage is that the kind of disclosure risk that we're worried about should be a lot reduced, right? Because there's no real record on the file. You know, there's no record to point to and go, that's Jerry, because it's not. It's all simulated, right? So this most of the attacks that people have have successfully perpetrated, at least in the literature, are ones where there's linking one file to the release data. That's like the Netflix challenge. I can tell you any of these in the question period. There are the Netflix challenge, the disclosure attack. They found somebody in the Netflix data for a competition by linking to other databases. So these sort of linking attacks don't really make a lot of sense when your records are simulated, right? So there should be low risk. I didn't say zero risk because there's still disclosure risks, and you can ask me about those, but it should be low. If we could generate data that capture a lot of the relationships and the distributional shapes, then we have the potential to do all sorts of things. Like we could preserve associations among variables, which we would have killed from swapping, for example. We don't have to chop off the tails. We can generate tails of income, right? We don't have to aggregate way up to the state level. We might be able to release simulated data at a small area level, right? So there's lots of potential if we can do this well. And again, it is a challenging if. But that's the idea. So this was proposed in 1993, and truthfully, it was sort of laughed off as that's nuts. But like a lot of Don's ideas, they seem to come back, and people, wind up seeing merit in them. So that's synthetic data. Okay, so that's kind of an approach I've been working on as a way to deal with some of these increased privacy and confidentiality risks that exist with some of the existing techniques that I put on the last slide. Okay. And this is actually happening. So it was laughed off in the early 90s, but now it's happening. So the Census Bureau, for example, has created at least 4 synthetic data sets that I'm aware of. One of them is called the Synthetic Longitudinal Business Database. I'm going to tell you about that a little bit. I was involved in the creation of that. One of them is the Survey of Income and Program Participation, the SIP. Perhaps some of you use the SIP, but it's the largest survey of people on public assistance, and it's really great because what this was headed by John Abad, whose name you may know as the Associate Director for Research at Census now, former economist at Cornell. But anyway, they wanted to link Social Security earnings and disability history to the SIP program participation data, and the IRS and Social Security Administration said, you can do that, but there's no way we're letting you release that to the public. No way. And so then they said, well, what if we made a synthetic data file? And IRS and SSA said, okay, you can do that. So they made a synthetic linked data file, which you can go download from the Census Bureau website right now. Same thing with synthetic LBD. You can download that as well. The American Community Survey, the group quarters data are actually what's called partially synthetic. Only a certain number of variables are synthesized, but that's another example. And then there's this On the Map, which has maps of where people live and go to work, the street blocks. And actually the street block where they go to work is fixed, but the street block where they live is synthesized from these multinomial distributions. That one actually satisfies a variant of differential privacy. The other 3 do not. Other countries, other agencies are doing this. National Cancer Institute has a product of the SEER registry that's partially synthetic. IRS is developing synthetic tax files. I'll talk about that one a little bit. In the UK, in Germany, in Canada, New Zealand, other countries. So the synthetic data idea is starting to catch on, I think, because of the privacy risks people realize that exist without extensive perturbations. So I want to tell you a little bit about synthetic data by walking you through an example. It's my favorite way. So I want to show you the results from the Synthetic Longitudinal Business Database, the LBD. So this is a data set that comes from administrative data. It's not a survey. You can access it, well, before we started, you could access it only through the research data centers, now the FSRDCs. This basically has one record for every business establishment that's been around in the United States going back to 1976. And it follows them longitudinally, collecting variables like how many employees do you have? What's your payroll? Are you part of a firm? It's updated every year. Economists who are interested in this data set for looking at things like job flows and market volatility and all sorts of things. So this is very, very sensitive data. It's Title 13 data, which is the reg for the Census Bureau. It's also Title 26 data, which is the reg for tax data. And basically, Title 26 is super powerful in the sense that even the fact that a person or establishment filed taxes has to be protected. Not a drop can be released, okay? And so the Census Bureau, the only way they could give access to these data was through the research data centers, and where people have to get approved and undergo background checks and et cetera. But they wanted to release a data set for the public to analyze. And so, so I worked with them, we worked with them, one of my PhD students also, to create a synthetic version of the LBD, okay, which is now again released and published, and you can go download it. So I want to tell you a little bit about the synthetic LBD and just show you some results so you get a feel for what's possible and what's not, and that'll lead into the vision as well. So here's the variables. This you'll see it says phase 2. We actually made a second version of it. It's kind of stuck there at the moment. But you can see, I'll go to the bottom. You can see we have geography, there's state and makes codes. Those are going to not be synthesized, and that's because that information is already released by the Census Bureau. You can get how many businesses in a particular classification code are in a particular state. You can even go down to the county level, actually. So we didn't release that. We didn't synthesize those. We fixed that since it's already available. But we synthesized everything else, starting with when the establishment came into existence, when it went out of existence, if it did. And then there are a bunch of annual variables. Is it active or not? Is it part of a firm, a multi-unit group? Your local McDonald's is part of the big McDonald's firm. How many employees, how much payroll, and then an ID for firms. Okay, so that's the data. It doesn't look like much, but over 30 years of data, you can get a fair number of variables when you multiply all these Y3 through Y7s by potentially up to 30. Right? Okay, so there's quite a bit of engineering work. And the way we generate the synthetic data, and this is my favorite way generally, and I'm not going to get into the weeds here, but basically we're trying to model those Ys given the X's. And so that's a joint distribution, and I'm going to model that thing by splitting it up into a product of conditional distributions. I find that to be a relatively flexible way to try to model joint distributions. And the nice thing about it is basically, I can regress Y1 on X, and then Y2 on Y1 and X, and Y3 on Y1, Y2 and X, et cetera. We do it by NAICS group. We have to parallelize this thing because it's 30 million records. And so you parallel process, you do it by NAICS group, and then just run lots of jobs all at once. Lots of engineering stuff. But the nice thing about splitting it up into conditionals is that you can use kind of whatever model you want that's tailored to the variable at hand, including non-parametric regressions or CART, classification tree models, multinomial distributions for categorical data. So it allows you to be really tailored, which is nice. So that's what we did. So I had a PhD student who just did an amazing job. She's at RTI now, and building the synthetic data set. So what kind of results can you see? So here's just one output. This is basically job destruction rate. So this is how many jobs were lost. And it kind of goes, the blue is the real data, and then we made 2 synthetic data sets just to see the variability. There's very little variability because this is large numbers. By the way, these analyses came from the Census Bureau. We didn't tailor our synthesis to kind of meet these. These were ones that the experts, the economists at the Census Bureau said, you know what a lot of people use this data for is something like this. And so you can see we do pretty well, right? It tracks the overall trends. There are places where we don't hit it so well, like we're a little bit off in looks like 2004, maybe around 1990. And I suspect that's some outliers that we may have missed, but it's not perfect. And that's an important caveat that'll lead to the vision. This is acquisition events weighted by the number of employees. I won't get into the details. You can see again, it does pretty darn well, not perfect, right? These are percentages. I mean, I was really happy when we saw this. This is a complicated event. that's not at all factored into our models. I mean, this gets created from the number of employees that we make. This is divestiture events. Okay, I'm not going to explain that, but this is a little more off, right? You could see we kind of missed some of these spikes. We're a little bit suppressed on some of these spikes. Okay, so the moral of the story is basically that the synthetic data can be quite useful, and I'll pause after this slide for catch-up questions. Synthetic data can be quite useful for lots of analyses, but they inherit whatever features we bake into the synthesis models, right? If we say that it's a normal linear regression, well, guess what? That's what the data are going to look like. If we miss an association between two variables, we forgot to include a variable as a predictor, the association is not going to be there in the synthetic data either, right? And so the quality of the results are, particularly for this fully synthetic data that we've made, are entirely dependent on the quality of the synthesis models. You will not preserve every analysis. That's impossible. Okay, if you do that, then you have the original data again, which is the privacy problem. So the hope is that we can preserve a lot of stuff and make it useful for a lot of analyses, but we know that we're not going to catch everything. Let me pause there and see if there's a question.
Jerry, it was like maybe 3 slides ago when you had all the variable names. And yeah, so I was just wondering, why would one bother to synthesize a firm ID? I would imagine that the ID doesn't relate at all to any of these things. Yeah, just why is that worthwhile to do?
Yeah, synthesizing a firm idea. What does that mean? So basically, we create these establishments, these local businesses, if you will, and then we have to lump them together into firms, right? And so we're synthesizing that process of which establishments belong to the same firm. And then once we put them in the same firm, that's what I mean by synthesizing a firm ID. We just make up a number for it. We don't use the actual number that comes from the LBD, I think. But that's the idea, synthesizing who goes together.
Okay.
Dr. Reiter, how do you choose that ordering for that conditional synthesis?
Great question. How do you choose the ordering? So honestly, it's mostly out of convenience. So for example, the first year that the company came into existence, that's a categorical variable that has up to 35 levels. And so I don't want to, I want to do that in the beginning because, it's relatively easy to do a multinomial distribution with 35 levels, but to do a multinomial regression with 35 levels, that's a lot of parameters. And so I'm happy to put that at the beginning. That's one reason. And two, some of it is logic, right? It's sort of, okay, well, company has to come in existence, and then if it comes in existence, it doesn't go out of existence. So there's a logical ordering to Y1 and Y2. And then the years, we kind of go sequentially every year, 1 year, the next year, the next year, the next year. In terms of why payroll after employment, honestly, I don't have real good reason for that other than that's just what we did. So it comes down to sort of computational convenience, what makes sense scientifically to help you with modeling, to specify reasonable models.
Jerry? I'm just checking my understanding here because, so as you put together the synthetic version of a data set, you're kind of smoothing out some of the noise that is built into it. But then if someone is really focused on identifying the spikes because of causal inference design, say, I'm trying to identify a shock or something like that, necessarily the synthetic data is kind of getting me out of that game, right?
That's a really good point, Marco. So if you're interested in analyses that really involve essentially very fine-grained points, right? Like you say, outliers, change points, things like that. We easily could miss those. I agree. I mean, if you upfront built it into the model, then you'd catch it back, but very often you don't. This is the price for privacy, right? There's a price to pay. That's a theorem, actually.
Yeah, but it sounds like the message, Jerry, then is that for someone interested on causal inference of specific events, taking part of the construction of the synthetic data becomes almost necessary at this point, right? Because I want to build my causal inference on the construction of the data of sorts. I cannot expect you to produce some data for me to analyze a problem, right?
That's right. So, so as someone who's created synthetic data, it's really important to have subject matter experts on the team to try to get as much of this as you can. You won't get all of it, but as someone who's analyzing the synthetic data, yeah, you got to know these limitations. In fact, what that really leads to is this next issue, which I'm happy to move to unless there's another question.
Yeah, Jerry, just one more.
Yeah.
On that slide where you had the list of conditional distributions, everything was given X. So are there some things in the data that are rooted there, or do you need to find the marginal distribution of X and simulate that as well?
So we had, in this work problem, we had state and NAICS codes that we left fixed.
Okay.
But you don't have to do this with an X. You could remove the X and it would still be fine.
Mm-hmm.
Okay, so I think some of the questions are hinting at this issue. How do we assess the quality of the synthesis, right? So, so this is an idea that that I've been working on, which is called a verification server. And the idea is it's a separate system that a computer system that has the confidential data, it has the synthetic or otherwise redacted data, okay? And the user who starts off with only synthetic data, you know, she submits a query to the verification system and says, you know, I want to fit a regression of variable 10 on variable 8, 6, and the log of variable 3. And the system, which has both data sets, computes the analysis on the synthetic and on the confidential data and reports back some measure of similarity to the user. How much of the confidence intervals overlap? How far apart are the point estimates? You can imagine lots of similarity measures that could be reported back. And then the user can decide if the results are sufficiently high quality for her purpose, whatever that is. Okay? So that's the idea of a verification system. There is a trick to this though, which is that, you know, as you release quality measures, you leak information about the original data, and someone who's clever about their queries might be able to triangulate into actual data values. And so you really have to think about applying disclosure protection to the quality measures as well. And that sort of gets to division, okay? It took us a while to get here, but and I hope I might run a little over the 50 minutes because of some of the questions. I hope you don't mind. Here's the division we've been working towards. It's sort of an integrated system that has access, that allows access to confidential data, which has 3 components. The first is the fully synthetic data, which we can share with the broad public, whatever that means. Okay, people get that. Second is remote access, which, you know, we're all familiar with the PRDN and other things of that nature, FSRDCs, for approved researchers, that they can actually get access to the confidential data. I think that's important. If you're going to do a giant policy question or a question that, you know, decides life and death decisions, you don't want to do it on synthetic data. You need to do it on real data. Okay, I'm not going to claim that. But sitting in the middle of this verification idea, okay? So people can you have the verification server too. So if you can have all 3 of these integrated together, right? The user starts with the synthetic data. He develops code, does exploratory data analysis, you know, figures out what are the right questions to ask. Are there enough people in this category that I'm really interested in to support the analysis that I want to do? Hopefully this synthetic data can give him some idea about that. Okay, then he could go to the verification system, right? And say, okay, well, was my analysis any good or not? And the verification system will give an answer. Maybe the answer is yes. If so, then he's done. He can publish in the broad sense, and not have to go through the hoops, the effort of trying to get access to the confidential data, which might, for example, with FSRDCs, might require a background check and time to write a proposal and things like this, right? So there's an advantage there. But if it's not good enough, that's if it was good enough. If it's not good enough, then they could go apply for access to the confidential data through the remote access, or even if they just wanted to confirm it because it's a really important policy question. But I don't think the user who's done this has wasted time by going through the verification, right? Because they're going to be far more efficient when they get to the real data if they've started with synthetic data. And that's important because a lot of times the FSRDCs, like you all know, they're not everywhere. Right? Even if we have one on Duke's campus, which is great, I highly recommend the FSRDCs for if you're interested in federal data. But we have one on Duke's campus, but you know, if you're at NC State or UNC, you've got to drive over here, you know, and so that's not so bad, I guess, but still, you want to be efficient with your time when you're doing that. Or if you live in a different state and there's one really close, that's, you know, that's a lot of work to drive there. Or you might have to leave your family for a few months. You know, you want to be efficient. Anyway, and then of course it's good for the whole system as well, because basically, you know, explorations, exploratory data analysis is all done offline. You know, it saves cycles for people to analyze the genuine data. So that's the vision I'll be working towards. You know, synthetic data, where are we now? Basically, is there off-the-shelf software to generate synthetic data? Well, there's some. I mean, there are a bunch of private companies that have popped up, and they're all selling synthetic data generators, particularly in the health space. Computer scientists have latched onto this idea and saw that as quite, they think it has a lot of promise. So you see a lot of private companies. In the software package R, there's something called SynthPop, which is a synthetic data generator. It uses some standard models like classification and regression trees. You know, my experience is that any real application like the LBD, you're going to have to customize it because the data are complicated and there's special things that you just got to build in. But these are good places. SynthPop is a good place to start. Are there sort of just general routines, general methods, you know, for kind of building synthetic data from models like I did with the LBD? Yes, there are all those kinds of models, and people are using regression trees a lot, actually. That's become quite popular because they're very, very flexible and easy, and they can work with large data sets and handle diverse types. So regression trees have become quite popular as synthesizers. One of the things about those is that it can be quite challenging to characterize the disclosure risks. Beyond saying, oh, you probably are not going to be able to link this record to another record. I mean, there are other disclosure risks. Maybe the synthesizer, you know, the only way it generates somebody that looks like this is if there was somebody in the real data that looks like that. You know, so, or maybe it's such a good predictor, like the R squared is 0.99999 or something. I mean, this doesn't happen, but you can imagine it could happen, right? That basically it reveals the original data values. So you do have to worry about it. I mean, we don't have great ways to do that, to be honest. It's very kind of ad hoc. That leads to sort of, there's been a big push in formal privacy, differential privacy being one example. A lot of theoretical development to try to create differentially private synthetic data sets. Census Bureau is doing that with 2020 files, for example. And you know, the census is really out front on that. I mean, they are the leading organization in the world on this, even beyond Apple and Google and those places. And so I think there's been a lot of theoretical development, not as much practical experience yet, but this is an important direction to pay attention to. Verification measures, you know, in some ways they depend on kind of who you want to allow to have access to the verification system. I mean, if it's like university researchers and you vet them and they promise not to do stuff, you know, you could probably be pretty light on your disclosure protection and the verification measures. It's not easy to back into original values unless you're really purposefully, you know, trying to do that with your queries. But if it's more broader, you're not as convinced that people won't do nefarious things, you can have verification measures that satisfy this notion of differential privacy. And we've created a bunch of those, including some of the ones that I list here. I won't read them off. But I'm going to show you under some results that with tests that coefficients exceed user-defined thresholds. A big question on these is, how do we scale up while respecting privacy budgets? That's been a challenging question for differential privacy with, where there are query systems involved. There has to, if you're going to follow differential privacy strictly, there's an upper bound on how much privacy leakage you'll tolerate, which translates to how many queries you allow. And once that bound gets hit, you're not supposed to release any more. And that's a challenge for this. And I admit to not having solved that. No one has. Okay. So that's a state of the art. I have an example that I want to go through. If you all are willing to let me walk through it, and that might take me a couple minutes over, and then I'll take questions, more questions at the end, if that's okay. So that way I can
Go ahead.
close to 50 minutes and not keep people over who need to go.
No worries. We have until 5, so regardless.
Okay, great. Okay. Yeah. Okay, so let me show you an illustrative application. And this came from a grant that I got from NSF, the Data Infrastructure Building Blocks grant. And it was to implement this system for data from the Office of Personnel Management, which is the Human Resources Department of the US government. And what we had was, we had a lot of data, but the one we used was basically a snapshot file called the status file. On every September 30th, the government takes a picture of what its workforce looks like and puts that information in a file, and it goes every September 30th, so it accumulates, longitudinal data file, okay? And so we have actually longitudinal work histories of civil servants from 1988 to 2011. That was the data file we had access to. It keeps going, but that's what we had access to. And so this is really interesting data if you are an organizations researcher. You can think of questions like, well, what are incentive structures in a large organization where it's hard to fire people, right? I mean, these are the kinds of questions that interest people with this data. It's data that Duke got a hold of. It's not public use data, although subsequently BuzzFeed got a hold of it and published a large portion of the variables in this data set. So it's effectively public use. Not to mention that this data set was part of what was hacked by people in China. So this data is arguably all out there anyway. But when we started, it was not. And it's his work histories on people. So it's got your career, where did you work, how long did you work there, where did you change jobs, demographics, education, race, sex, what grade and step. Those are determinants of your salary and the salaries information. So about 40 or some odd variables that we had longitudinal history. So it's set up a lot like the LBD, and that it's longitudinal, and people are coming in and leaving at different times, and more variables, but much smaller. About 2.5 million employees overall. We didn't include people that carry guns because we thought that was too risky to work with. Okay, so basically everybody else except national security people. The sad story here is the data did not get released. And I can tell you the sad story about that if you want, but it had to do with the timing when the 2016 presidential election, with a switch in the administration, and there not being an OPM director for more than a year, and then this project, our contact leaving OPM and it falling off the radar, and black hole emails, and anyway, it's a depressing story. It's all done, but it's a depressing story. Anyway, so I'm telling you basically results of a paper as opposed to an actual data product. It's still a great paper, I'm proud of it, but it would have been cooler if we had been able to release the data product for sure. Okay, so that's the deal. I'll show you the paper reference later. Okay, so we make this synthetic data set. We simulate these employees' histories, okay? And I'm not gonna go through that, you can read the paper, but I wanna go through the analysis to illustrate this synthesis and verification idea. Okay, and the analysis, we have a bunch of analyses in the paper, but the one I'm going to show you today is basically a regression of log of the basic pay, the salary of the employee without any adjustments for location or bonuses or that kind of stuff. So log basic pay for employee years, so using all employee years as the rows. So it's like 13 million rows or so, but well, for men and another 13 million rows for women, because we model it differently for men and women. And we do clustered standard errors to account for the dependents. Not that they matter, because for 13 million, it doesn't matter. But anyway, and we regress on demographics, including race. And the substantive question that our colleagues who know science, I know the stats, or know the science we're interested in is, are there differences across race by gender in pay in the federal government, controlling for education and occupation, and we can argue about whether you should control for those things or not. We talk about that, but that's the basic idea: age, things like that. Okay, so we made this giant synthetic data set. It's done. My postdoc spent a massive amount of his time doing it. It's great. He did a great job. And there's some interesting findings that happen in the synthetic data. So when we do this regression, we find that the regression results suggest that the median pay for Asian men was about 2.8% lower than the median pay for white men, holding all else constant. Okay, so that was a surprise to us. And there's like, tens of thousands of records. These are all way beyond statistically significant. Okay, so it was a surprise to us. We were like, maybe that's the synthetic data. And maybe we really messed up on the synthetic data generation, because we were surprised by that. We just didn't expect that. Okay, and then there's another finding that Black women have a higher median pay than white women, but this turns out not to be statistically significant despite the massive sample size. It's a really tiny difference. And we wanted to see, was that from our synthesizer, or is that hold up in the real data? Okay, so these are the kinds of analyses that people might do with the synthetic data, and then they get these results. Should they trust them or not? Well, that's where you want to go to verification. Okay, so let's talk about verification. Okay, so we created some verification measures, and the verification measure that we created is the following. Basically, we let the user pick a threshold that represents what she or he thinks is a measure of a practically significant result. Not statistically significant, because everything is statistically significant, basically, but practically significant. And so, for example, we talked to some people in the law school, and they said, you know what? If we saw a coefficient in front of a race variable that was minus 0.01 or less, so basically roughly about a 1% difference in pay or less, that would give us some cause. Maybe we would go to court on that, right? And so we said, okay, threshold of minus 0.01. So we're actually interested in the question. Basically, we want the user to be able to see if the true coefficient, i.e. the coefficient from the regression on the confidential data, if the true coefficient in this regression is less than minus 0.01 or not. Because it was minus 0.028 in the synthetic data. Is it minus 0.021? So that was a verification measure. You can adapt this thing to test if the true B is within some tolerance interval of the synthetic estimate. That would also fit into this. Okay, so that'd be another verification. I'm going to show you the one with the first bullet. Okay, and basically we create this verification measure, and it has a property of differential privacy. Differential privacy is a criterion, a disclosure risk criterion, a privacy definition, comes from the cryptography community that basically instantiates the notion that a statistic shouldn't change very much due to the presence or absence of any individual in the data. So somebody who could choose to participate or not in the data, it won't change the value of the statistic that results very much. So therefore, their information is not affecting the result. That's privacy. Okay, so that's intuitively what differential privacy means, and I can answer a lot more questions about differential privacy in questions if you want. But anyway, we create a verification algorithm that satisfies differential privacy, and it basically tries to estimate the probability that beta is less than minus 0.01. So it's a Bayesian idea. It's a Bayesian thinking. Okay. Because B, of course, is a true coefficient. And it'll output, actually, this R, we can't learn it exactly because of the noise from the differential privacy. So we actually output a credible interval, a posterior mode for R. So you could do things like, okay, well, if we think R is between 0.92 and 1, that's telling us that we think there's a pretty good chance that the true coefficient is less than minus 0.01, the threshold we made. So we feel like, if that's our condition for verification, it would be satisfied. On the other hand, if it was like between 0 and 20%, then that would tell you that it's unlikely that the true coefficient was less than minus 0.01. So you shouldn't trust that minus 0.02a from the synthetic data that you got. Okay, so that's just some intuition. So this is, I'm not gonna go through the verification measure because of time. If you have questions, I can come back to it. But this is the results that we get. This is taken from the paper, which I'll flash up at the end of the talk. So this is with a differential privacy epsilon of what's 1. If that means something to you, great. If it doesn't, it's sort of like not a huge amount of privacy, but not nothing either. Okay. The threshold that we did is minus 0.01. This is all the synthetic data results. I, not put in all the dummy variables for occupation and agency and stuff like that. They're all in there, but obviously that's hundreds of variables. So this is just the key variables. There's that minus 0.028 I talked about. There's this is the men. Sorry, not the This is the minus 0.028. The bullet about the black women is for women. Okay, so that's the synthetic data. That's all you get with the synthetic data. I'm just going to skip over. Here's the confidential data. This is the actual results. So you can see, it mirrors it pretty well. It's not obviously not exactly the same, some attenuation across the board. It's not surprising with synthetic data, but you get more or less the same general conclusions. And this is the verification measures in here. So if we look at that Asian one, this basically 0.99 is saying to me, look, there's a 99% chance, this is the mode of R, 99% chance that true coefficient was less than minus 0.01. And it was minus 0.04. So it's telling me the right thing. So it had that for all these ones where it was, the true coefficient was quite a bit away from minus 0.01. A little bit less when the true coefficient was minus 0.019, but still kind of, favoring that way. What would you do with this? I mean, what do you do with a p-value of 0.06? I mean, you've got to interpret this and decide for yourself if a 76% chance is enough for you to feel good about it or not. But overall, I think it does a pretty good job of tracking. Here's the females regression. You could see that here's the black women. You can see that very small positive coefficient with a standard error that was essentially big enough to kind of rule this thing as not significant despite the massive sample sizes. Okay. And we even see in the confidential data that was seemed not to be significant here as well. Okay, so again, if I look at that 0.003, that's telling me, well, it's very, very unlikely that the true coefficient is less than minus 0.01. The chance of that is like 3 in 1,000. So, and that's the right decision, right? I mean, the fact that it's minus 0.03 and 0.03 is a pure coincidence. But that's the right decision as well. That's interesting when the Asian women, I think is interesting because it's 0.42 and you might be like, well, what the heck do I do with that? That's like, it might be, it might not be, but that's actually the right decision because the true coefficient is exactly minus 0.01. And so the algorithm, the verification measure is telling you, I don't know, it's right on the line. And so it might be, it might not be. And so it's actually a reasonable piece of information to get, okay? So that's the idea. We have much richer analyses with longitudinal. There's some really interesting trends. If you're curious about the substantive problem with the confidential data, about trends of pay by race and sex over the years, longitudinal analyses, I think are more interesting even than these. I'll refer you to the paper. But that's this is the summary. That's what we talked about it. 2 slides, and then I'll end for questions. So this verification measure. I mean, our experiments say, we took advantage of the very, very large sample sizes here. Essentially, those coefficients have practically no sampling uncertainty to them. And so if there is sampling uncertainty, then we don't account for that. There's that doesn't make it into our measure. I mean, we tailored it to the particular problem, right? So you have to do some other verification measure like the significance test measures that we have. One thing that we came upon, which is sort of interesting, you could actually have in this verification measure. Well, I skipped the slide, but what we do is we chunk up the data. Instead of doing it all at once, we split it into 100 disjoint, randomly sampled sub data sets, and then we run the regression on each of the 100. Okay, and the sample sizes are still very large generally in those, so the estimate that you get is still pretty accurate. And that helps us figure out these probabilities. It's basically the fraction of times of that, the coefficient's less than the threshold in each of those 100 data sets with some noise added to it to protect for differential privacy. Anyway, but you can actually get an undefined, like you could have a partition, a data set where there's nobody of your particular dummy variable, and it can give you an undefined in your regression and error. So that was something we didn't think about when we started, but so now we've created a measure that has an error, a randomly generated error, number of partitions where there's an error in the regression model. So anyway, these are things you have to think about with this. Okay, let me conclude, show you to the paper, and then I'm happy to take questions. So this notion of giving people a synthetic data set to start with, and then enabling them to analyze the real data or get results on the real data, either through verification or through remote access, is gaining a lot of momentum. So I mentioned the Statistics of Income, IRS. They have actually created a synthetic tax file. So people want to do microsimulation modeling with tax records. What's the effect of this tax policy? Well, we need a tax data set in order to see the effect of that on various outcomes. So you need tax data, but tax data are protected. They have released tax data in the past. You may remember, you may not, but you may remember, I think it was early on in President Trump's tenure, the New York Times actually went ahead to one of those publicly released tax files and got a little bit of inside information about one of or two of President Trump's numbers that he would have answered for some of the fields on those files, and was able to essentially say, that's President Trump's record, and they identified his tax record in the supposedly anonymized file. Okay, that's the linkage attacks I talked about, right? Anyway, so they've made a synthetic tax file, and they're actually currently testing out. They're not doing verification. They've actually gone directly to validation, which is to have the server, instead of reporting a similarity measure, to have it report a noisy estimate of the actual answer. Okay, that's a slight variation, and I can talk about the differences if you're interested. And the Census Bureau has been doing this validation in synthetic data, the LBD, the synthetic SIP. There's other products that I won't say what they are, but those of you who've been following things may know that they're working on this similar idea for it. If you're interested in the manuscript, you can find it on archive, or the published version is in the Annals of Applied Statistics in 2018, and if you are curious about the title, it is share. Oh, Asher, sorry, I kept hitting the wrong button. That's the actual paper, including a whole bunch of excellent dookies as well. So I'll stop there. Thank you for entertaining me about 5 or 10 minutes beyond the 50. I appreciate it. I'm happy to take some questions.